All right, for homework 24, the first two problems say use a graphing utility to graph the integrand. Use the graph to determine whether the definite integral is positive, negative, or zero. So I left my screenshot up here, but I want to remind you how to graph just the window of interest quickly. So if I press y equals, and I can either do type in 4 over parentheses x squared plus 1, or remember alpha y equals gets you to the fraction key. So sometimes people get confused about parentheses. So either way, you need to graph this expression. I only want to look on 0 to pi, so I'm going to go to the window and set this to 0 to pi, and then I choose zoom fit, which is option 0. And that shows me just the section of interest. So because these values are positive, you can be sure by tracing all of these values are positive. This will be a positive area. So the integral from 0 to pi of 4 over x squared plus 1 dx will be greater than 0 because the entire graph is above the x-axis. And then if I do the same thing for cosine of x, make sure your calculator is in radian mode for the calc exam. The window again is 0 to pi, and then I'll zoom fit because it might be different. Excuse me. Okay, so looking at this, this looks symmetric to me. I'm not, you can be sure by like tracing values and seeing that you have on opposite sides, you're going to have the same type of values, but I'm pretty confident that this is net 0. So the integral from 0 to pi of cosine x dx is equal to 0. For this section, it says evaluate the definite integral. Use a graphing utility to verify. So I left that work up here. I'll show you once how to get this, and then you can just confirm on your own. So I want to find the integral. So t squared becomes t to the third over 3. Minus 2 becomes minus 2t. We are evaluating from negative 1 to 1. And remember, this is fundamental theorem of calculus that says we should plug in the 1 first. So 1/3 minus 2 minus, well, what do we get when we plug in negative 1? Negative 1/3 plus 2. And if I'm not using a calculator, I usually, we have some like similar terms here. So I usually do 1/3 plus 1/3 is 2/3. And then negative 2 minus 2 will be minus 4. And then I'm thinking, okay, minus 4 is really minus 12/3. So negative 10/3. And I can confirm that on my graphing calculator. So you don't need to graph the thing every single time. Remember, it's much easier to do this on your home screen. So go to your home screen, press math. 9 is function integrate. Give it the bounds, negative 1 to 1, and type in your function, x squared minus 2. Tell it what we're differentiating with respect to. We can only ever type x in here, so you don't have to worry about changing it to t. And again, yes, we get negative 10/3. All right, so I'm not going to check every single time. I did here on the answer key. You can verify separately if you need practice typing this stuff in. Otherwise, we're just going to keep going with our work. So the integral of u is u squared over 2. This is u to the minus u to the negative 2 right now. So if I add 1 to that exponent, I'm going to get minus u to the negative 1 divided by the new exponent. And before you go plugging numbers in, you should simplify any negative exponents so that you don't screw up the math on this. So this is u squared over 2. Minus negative is going to be plus, and then instead of u to the negative 1, it'll be 1 over u. All right, and then remember you're plugging in the top number first. So negative 1 squared is 1/2, plus 1 over negative 1, so minus 1, minus, plug in negative 2, you get 4 over 2, which is 2, and then plug in negative 2, minus 1/2. So again, I'm going to do like terms. 1/2 plus 1/2 is 1. Negative 1 minus 2 is negative 3. So I'm getting negative 2. And if I check this on my calculator, I also got a result of -2. For this one's going to take a little bit of algebra before I get started. We can't just say this is 2 over x to the 1/2 power because we haven't talked about u sub yet, so you need to work on this a little bit. The square root of 2 over x is the same as the square root of 2 over the square root of x. So that means I can rewrite this integral. I'm going to pull a radical 2 outside, just so it's out of my way. And then instead of 1 over radical x, I'm going to make that x to the -1/2. Now it's easier to look at, and I add 1 to my exponent, so I get x to the 1/2 divided by that new exponent. Simplify that to make the math easier. So instead of dividing by 1/2, I've got 2 times x to the 1/2, going from 8 to 1. So you could factor the 2 out. I'm just going to leave it. So when I plug in 8, I get 2 radical 8 minus 2 times radical 1. Clean this up a bit. 2 times radical 8 is 4 radical 2. 4 radical 2 times radical 2 is 4 times 2. So that's 8. And then radical 2 times -2 is just minus 2 radical 2. If I check on my calculator, I got this decimal answer, and then I verified that 8 minus 2 radical 2 is that same decimal answer. Same directions for this section. It says evaluate the definite integral of the trig function. Use a graphing utility to verify your result. All right, so the integral of 1 will be x. The integral of sine is minus cosine x. I always do a quick mental check here. If I take the derivative of negative cosine x, I get positive sine x because it's easy to miss the plus or minus sign. All right, and then evaluating this, we plug in pi to begin. Pi minus cosine pi minus 0 minus cosine 0. With trig, I would suggest before you simplify the trig value, showing yourself just the angle plugged in so that, again, you don't mess up positive and negative signs. So this is pi minus -1. The cosine of pi is -1 minus 0 minus 1. Cosine of 0 is 1. So this is pi plus 1 plus 1. So pi plus 2. And you can verify on your calculator. For this one, the integral of 2 is 2x. What's the integral of negative cosecant squared? Okay, so you're trying to think, what thing has this derivative as cosecant squared? So that's cotangent squared, plus cotangent x. And again, double check that. What's the derivative of cotangent? Negative cosecant squared. So that should be a plus. If you're a little rusty on those, this is something to study. Part of it is memorizing. Part of it is, I just have a few of my trig derivatives memorized, and then I can go from there. But yeah, it just might take some studying. And then when we plug in pi over 2, 2 times pi over 2 is pi, plus cotangent of pi over 2, minus 2 times pi over 4 is pi over 2, plus cotangent of pi over 4. Okay, so pi plus cotangent of pi over 2 is 0. I know that one quickly because I know tangent is undefined, so cotangent is the reciprocal of that, which is 0. Minus pi over 2 plus minus pi over 2 minus, because I'm distributing, the cotangent of pi over 4 is 1. 1 pi minus 1/2 pi is 1/2 pi minus 1. Verify on your calculator. All right, determine the area of the given region. So it's hard to see, but this is shaded pink between 0 and 1. So I'm being asked to find the integral from 0 to 1 of x minus x squared dx. So the integral of x is x squared over 2 minus the integral of x squared, x cubed over 3. Go from 0 to 1. Plug in 1 first, you get 1/2 minus 1/3. Plug in 0, you get 0 minus 0. I always like to show that to myself just to verify, because sometimes there's a trig term or there's something that doesn't just calculate out to 0 when you plug 0 into it. So it's worth writing down. 1/2 minus 1/3, so that's 3/6 minus 2/6, that's 1/6. For number 36, the shaded region is here. So this is the integral from 1 to 2 of 1/x squared. So I'm going to write x to the -2 dx. That will make my exponent rule easier. When you add 1 to that exponent, you get x to the -1 over -1. And then you should simplify that. So that's just -1/x. Plug in 2 first, -1/2, minus plug in 1, -1. -1/2 plus 1 is 1/2. This one is shaded from 0 to pi over 2. So we want the integral from 0 to pi over 2 of cosine x dx. So what's the integral of cosine? Sine. Quick check, derivative of sine is cosine, okay. And then from pi over 2 to 0. So this will be sine of pi over 2 minus sine of 0. And that will be 1 minus 0, so just 1. Next set says find the average value of the function over the given interval and find all values x in the interval for which the function equals its average value. So first thing is to find the average value. I like to write this as f average. It's equal to 1 over the difference between the intervals, so 3 minus -3. And then you're multiplying that by the integral from -3 to 3 of 9 minus x squared dx. This is a formula to memorize, but if you think about what you're doing, if I want you to find the average of something, you add up how many there are and divide by the total number. It's kind of what we're doing. We're adding up all of the y values and dividing by the distance of the graph, like the span between the x's that we're finding. So you're finding an average y value. And adding them all up and dividing by how many there are. All right, so this becomes 1/6. And then the integral of 9 is 9x. And the integral of x squared is x cubed over 3. And we're going from -3 to 3. So that's 1/6. So 9 times 3 is 27. Minus 3 to the third is 27 over 3. 27 divided by 3 is 9. So 27 minus 9. Minus, when you plug in -3, you get -27. And then you're going to get plus 9. All right, so this is 1/6. And I'm getting, let's see, so 27 plus 27 is 54. -9 minus 9 is -18. 54, let's see, 54 minus 18 is 36. And I'm getting an area of 6. I don't remember those numbers, so I want to see. Why do I feel like I got 5 or something? Hold on. Let me double check, see if I screwed something up here. Oh yeah, why did I do the math like that? Okay, anyway, 27 minus 9 is 18. Is that what I had here? 27 minus 9 is 18. Is 18 minus -18. Okay, so that's 36. Okay, so that is 6. Is that not what I had on my answer key that I posted? Let's see. Oh, a 9th. Whoops. On my answer key, I screwed something up. I will fix that and then repost. Okay, so anyway, I'll do that later. This is the correct answer for the average value. So 6 is the average value. Okay, and then we were also supposed to find all values for x for which f of x equals 6. So when is 6 equal to 9 minus x squared? So add x squared over here, subtract 6. When x is plus or minus radical 3, both of those numbers fall between -3 and 3. They're like 1 point something. So yeah, those are the two values there. Okay, and then what about cosine x? So f average is equal to 1 over pi over 2 minus 0 times the integral from 0 to pi over 2 of cosine x dx. Now, 1 over pi over 2 is just 2 over pi, right? 1 divided by a fraction is 1 times the reciprocal. And then the integral of cosine is sine from pi over 2 to 0. So 2 pi times the sine of pi over 2 minus the sine of 0. Sine of pi over 2 is 1. Sine of 0 is 0. So 2 over pi is my solution. That's the average value of f. So we're saying on this graph, the average y value is here. And then we're supposed to find when is cosine x equal to 2 over pi. I would need a calculator to get an actual numerical answer for this. I can say x is equal to whatever the inverse cosine of 2 over pi is. So if it's a non-calculator problem, this is what I would answer. But I can approximate on my calculator. So again, make sure you're in radian mode, and then it's second cosine to get the inverse cosine of 2 over pi. So this is my answer in radians, 0.881. There's no label on that. You could write radians if you want to. That is between 0 and pi over 2 because pi over 2 is like 1.57-ish radians. All right, for this problem, the graph of f is shown in the picture. Evaluate the integral from 1 to 7. So I'm going to put in some labels here. It's already a little bit divvied up. I've got 3 trapezoids and a rectangle. So the trapezoids, I'm just going to make a note to myself what the base numbers are. So what are these lengths here? And then this span for the rectangle from 4 to 7 is 3 units. So for part A, the integral from 1 to 7 of f of x dx is just the area between the curve and the x-axis. So area of a trapezoid is 1/2 times the height, which is the distance between the parallel bases, so 1, times the sum of the bases, 3 plus 1, plus, now I wrote these separately on my key, but these are equal trapezoids. They have equal area. So you can say like 2 times 1/2 times 1 times 1 plus 2. On my key, I wrote them out separately, but there's 2 of those. And then the rectangle on the end is plus 3 times 1. Excuse me. So 1/2 of 4 is 2. 2 times 1/2 cancels, so this is plus 3, plus another 3. So that area is 8. And then part B says determine the average value on the interval 1 to 7. So f average will equal 1 over 7 minus 1 times the integral from 1 to 7 of f of x dx. Now, I just found this answer, so don't do the math all over again, but this is 1/6 times 8, which was the answer I just got. That reduces to 4/3. That's the average value. And then for part C, determine the answers to parts A and B if the graph is translated 2 units upward. So rewrite that integral to begin with. It's the integral from 1 to 7. Instead of f of x dx, it's f of x plus 2 dx. And we've looked at this before. That's the integral from 1 to 7 of f of x dx plus the integral from 1 to 7 of 2 dx. Remember this, if you want to draw the picture for yourself to help, this is just a little rectangle. There's a constant function with of 2, and you're just finding the area of the rectangle between it. So it's got a base of 6 and a height of 2. And remember, we don't have to recalculate this. We found this answer in part A. So 8 plus 2 times 6, 8 plus 12, 20. And then what would the new average value be? So it would still be 1/6, but it would be times the integral from 1 to 7 of f of x dx, f of x plus 2. I need parentheses around that expression, dx. So that would be 1/6 times the integral from 1 to 7 of f of x dx plus 1/6 times the integral from 1 to 7 of 2 dx. And again, we've done the math on these. 1/6 times 8 plus 1/6 times, what did I get when I did this integral here? I got 2 times 6, which was 12. So 4/3 plus 2. 2 is really 6/3. So 10/3 was my average value. All right, last problem here. Make this a little bigger. The graph is shown in the figure. The shaded region A has an area of 1.5, so this is negative 1.5. And then the integral from 0 to 6 of f of x dx is 3.5. So that's not region B, but I can figure out that region B is 5.0 because the net area has to be 3.5. So negative 1.5 plus 5 must come out to 3.5. All right, so what's the integral from 0 to 2 of f of x dx? That's negative 1.5. They didn't fill in the negative for you. You have to know that because it's underneath the x-axis. From 2 to 6, so B, I already answered that. That's 5. And that's because I know this is negative 1.5 and the net has to be 3.5. So if I add, or if I figure out what I need to add to negative 1.5 to get 3.5, I get 5. What does an absolute value do to the graph? You can actually visualize this. You don't have to visualize it, but instead of this being down below the axis, it would be a symmetric shape, but above. So something like that. And then the positive part would still be up there. So both of these areas would just be positive now. So 1.5 plus 5 would be 6.5. What if we have a negative 2 out in front of our integral from 0 to 2 of f of x dx? Well, that's just negative 2 times that answer, negative 1.5. So that's positive 3. And then just like we did in the last problem, what if we add a 2 here? So if we add a 2, we're going to get 2 times 6 minus 0 plus the integral from 0 to 6 of f of x dx. All right, so the integral from 0 to 6, remember they gave us that. That's 3.5. So 12 plus 3.5 is 15.5. And the average value over the interval 0 to 6, so that's saying 1 over 6 minus 0 times the integral from 0 to 6 of f of x dx. That's 1/6, again, times 3.5. So 3.5 is 7 over 2. So 7 over 12. All right, that finishes homework number 24. Please come see me in office hours if you have any questions.